All right, let's check how you did on your hypothesis test with two proportions. So here we had this problem where our parameters were P with the little subscript J was my proportion of all such Jenny O chicken packages with that Campylobacter contamination. Make sure it's in present tense. And here was the proportion of all such store brand chicken packages with that Campylobacter contamination. Make sure it's in present tense. And so our null hypothesis is that those are equal contamination rates, but we were wondering if shoppers are safer with buying the Genio, so that would mean lower contamination rate for the alternative. Okay, so for our assumptions for both of these, I color-coded them so it's kind of easier to see that I have both represented here. So for the random, I'm assuming that I had 156 randomly selected packages of Genio chicken and 150 randomly selected packages of store brand chicken. So those are my two samples. And independent is that small enough to not be making a difference. So those 100, I think I wrote those numbers backwards. So that should be 156 is less than 10% of all such Jenny O packages. And 150 is less than 10% of all such store brand chicken packages. So I need to fix that. Was a 6 and that one's a 0. Okay. But don't forget this little thing right here where we have this. This was the new little thing that we had to add to our independence, saying we are assuming that the Genio and store brand packages are independent. Those chickens are independent of each other. So none of those packages were counted in both of our groups. All right, so our large enough. So see, I had to show, it would have been nice if I had labeled this here, that this was the Genio, and then labeled this one over here, that was the store brand, instead of just having kind of like these these sets of numbers. Even though I color coded them, that would have been nice to do a quick label. So that I've got the Genio ones so I have 10 successes and at least 10 successes and at least 10 failures for Genio, and at least 10 successes and at least 10 failures for the store brand. Okay, so the approximately normal model applies. All right, so we have a 2 proportion Z test. I went and put it into my calculator. And so here you can see the numbers I put into my calculator. I was checking to see if P1 was less than P2. And when I calculated it, it gave me this Z-score with this P-value. So don't you dare just put P equals 0.0117 like they have on the calculator printout. That sounds like a proportion. This is a P-value. That's the area in that curve. So our p-value is less than our alpha. We did not give us a significance level, so that was our assumed or our default alpha. We reject the null hypothesis because that p-value is low. So we reject HO. Since the p-value is less than alpha, I reject HO. So if I'm rejecting HO, I have evidence that the proportion of Genio packages contaminated with the Campylobacter is significantly less than the proportion of store brand packages contaminated with Campylobacter. So it appears to indicate that shoppers would be safer purchasing the Genio product over store brand. See, this is going to tell me, should I pay more for the Genio over the store brand? All right. So then we went on down to this last part here where we skipped number 2 for last night's assignment, and we did another hypothesis test. Here we go. We were wondering, this is a good one. We were wondering if there was a significant difference. So this is, we don't know higher or lower. I'm just wondering if it's different. The proportion of men versus the proportion of women who think men can be described as intelligent. Okay, so let's see what our results are. So you can see my proportion of American men who think that men can be described as intelligent versus P of W is the proportion of American women who think that men can be described as intelligent. So let's see what our numbers show us. Now, our null hypothesis, of course, we start off just saying they have the same rate of opinion. But alternatively, see, we had a two-tailed, because if you remember down here, it said, does this indicate that there is a difference? Okay, so because it's asking if there is a difference, then that's why I did the two-tailed. Okay, all right, not equal to. So for my assumptions, random, I have the two different items stated that we had 506 randomly selected men and 520 randomly selected American women. Independent, the 506 is certainly less than 10% of all such American men, and 520 is less than 10% of all such American women. And here's that new thing, American men and women groups are independent of each other. And so then again, it would have been nice if here I would have defined it. And I think I'm going to go back and put this on the answer key before I load it. This, I would say, this is for the men, and then over here I would say this one's for the women. So label those so there's just not these random numbers thrown in there. Let's organize it so it's very clear what you are communicating. So they were both greater than or equal to 10. Approximately normal model applies. So we have a 2 proportion Z test. So here's what I put into my calculator. Those are the numbers that went in there. So again, what you see here is we had gotten that 28% of the men and 24% of the women. So yeah, it's less women, but is it significantly less? Okay, let's see. So do you see that when I multiplied this, it was 141.68 men. So when I put it in my calculator, it was 142. Okay. All right, so I ran that test for look at my tail here, not equal to, and I got a z-score of 1.47 with that p-value 0.142. Pretty big. So since that p-value is greater than alpha, I failed to reject that null hypothesis. Okay, not a big deal going on. So since that p-value is greater than alpha, I failed to reject the null hypothesis. There is not evidence that the proportion of men who think men can be described as intelligent is very different from the proportion of women who think men can be described as intelligent. So see, this just goes to show you that at first glance, an uneducated mathematician or an uneducated statistician would say, oh, yeah, look, women is numbers lower than the man numbers. So definitely. But, is that just sampling variability or is it a significantly lower amount? Okay. So that is what we know and what we can conclude. And so there is our end of our two phantoms of our two proportion hypothesis tests. All right. Then I will see you with our panic in the next assignment.